Hello, and welcome back to the Enterprise Decision Management Screencast Part 2. My name is Chris Wise. I'm a software engineer at Applied Engineering and Information Technology Group out of Charleston, South Carolina. This screencast can be viewed on YouTube or linked from my blog at harborsite.blogspot.com. In part one of the screencast, we covered the overview, the rules, what rules are, drools, the implementation of rules, decisions and enterprise services. Here we'll delve into the business case, which is a sample business case created to support the demo application that comes last. As part of the business case, we'll be exploring what our desired business outcomes will be, the requirements for our demo, and the design of our demo. So the desired business outcomes, or what the business expects our software or services to provide in support of the business. They want to dynamically change product prices being displayed at the online store based on the users, customized to the users themselves somehow, based on attributes that we're going to get from their browser. Now, this actually was in a story on CNN that I watched, that it was encouraging users to clear the cookies and browsing history prior to going to an online store, due to the vendors parsing that information and perhaps making some negative assumptions about it, although my expectation would be that they are making assumptions that are beneficial to the users, trying to steer them to a certain product set or things that they know they like. But it could, in fact, also have something to do with the price that you pay for a product. Now, in our case, the business experts at fictional.com believe that the operating system that a user shows up with is somehow indicative of their ability and willingness to pay a certain price for our products. So whether or not this assumption by our business is a good business model or makes good business sense, I don't know. One thing I do know, though, is that because I'm going to be implementing this using rules and decision service, I can quickly deploy and turn on and turn off these features and make adjustments to this pricing model without having to fundamentally change any of the processes already in place at the online store or systems that support that. So this is a simplified use case for a demo, and if I were implementing this, say, in servlets, I would be more than likely to just write a filter or put this in a JavaScript function at the presentation layer if this is truly all I was tasked to do. But you can imagine where you have a more sophisticated model, such as the airlines, who dynamically price tickets based on a very large number of variables that are rapidly changing. Variables like the overall popularity of a route and the current weather conditions and likelihood of the flight to be canceled, or the cost of fuel, the number of seats remaining on the plane. All these things go into figuring out how to price a seat on a flight, and you can find that out if you are a frequent traveler and you are on these online sites looking at tickets, and you lapse and go back 10 minutes later and find the price to be dramatically different. So in that case, it seems to be an excellent opportunity for the power of, say, rules and a decision service to come into play. The requirements for our desired business outcome, functional requirements, they all appear testable and traceable, so that's a good thing. In part one of the screencast, I mentioned the natural fit for decisions to be services due to the innate nature of decisions and their corollary to the principles of service orientation, primarily being stateless, autonomous, and loosely coupled. And I gave an example of how decisions and the criteria driving decisions are more frequently going to change than the business processes. I want to talk a few more seconds about this. While decisions share some of the same characteristics as optimal services, they also share some of the same pitfalls and challenges during design. A key watchword for rules is composability. And also, for example, if I were to design rules without regards for autonomy and loose coupling within decisions, then I'm losing some terrific advantages of rules. The corollary to service-oriented computing here is rules as services, rule flows as orchestrations, and decisions as outputs. The Drools fundamentals. The runtime environment for Drools is very light. Rules compiler and a couple of core components packaged as jars with your service. Probably small enough for an Android deployment even. The rules themselves can be embedded in the applications or managed from a business rules management system. In Drools, this is known as the Drools governor. For non-Java based systems, there's actually a declarative server that you can deploy to run rules from. Working memory is where the facts are stored. Rule facts, results, and queries. And comprising that are non-volatile facts, or facts that are not likely to change. So in our demo application, it's the prices of the products. So they're wholesale prices, and we would imagine that we're only going to update those quarterly or biannually or however we do it, but it's not something that rapidly changes. And then when it does change, we would simply reload the service at a downtime to get that information back into working memory. The instance facts are the facts regarding the most current situation that we can't anticipate. So that's passed at runtime. In fact, for the service, it's over the wire, so we want to keep that as small as possible. This is the microarchitecture that we'll be using for the demo application. This is actually a design that I put together for another project that I didn't get to work on. So I decided to use it for this demo app, so the exercise in design, not a total waste. What you'll notice is the decision service embedded in the JBoss application server. This will also be where our web application for the online store will be running. And the web application, I say web application, it's actually a more typical Java enterprise deployment servlet with beans-backed logic. The governor will actually also be on board the application server and not separate. Here it looks as it's almost displaced, but it's in fact running as a WAR file inside of the application server as well. Let's scrunch that up so we can see it. So we talked about working memory a few seconds ago and non-volatile facts. And one of the key components of the design is how to load the non-volatile facts for use by the rules engine. And here's a sequence diagram that explains how we are actually going to get the product price data into our working memory. Now, while I'm showing this, I'd like to take a minute to plug Jeff Davis and his blog. Although he has a new blog, the link to it doesn't seem to take anywhere where there's any material. Most of the design I have stems from reading about his ideas, although the implementation Jeff writes about are typically more of a pure service-oriented environment built using service assemblies and wide collections of various open source systems, where mine are just humble J2EE and web service integrations. But it's people like Jeff and the authors and architects of open source software that have really changed software engineering in the last 20 years for the better, and part of the reason why I'm now screencasting. We'll be revisiting the design diagrams as we hit the implementation, but one thing to sort of look at now is where are these components and whose responsibility are they? So we know as the decision service authors, we're accessing a data access component that can somehow get to the data entities for our client service. Where is that data access component going to be able to pull those entities? Is it going to be compile time linked to the client service, or will we bubble those up as service data objects? And that's something that we'll talk about as we move forward. This sequence diagram shows the flow from the customer request through the servlet to our decision service and back. At 1, after the customer request is made, the web bean, before we came along, would have just pulled the current pricing from the data object and returned it to the servlet for display. Instead, that bean now becomes a client for our service. Once our service has the request, we'll pass it to a decision processor where the decision will be made as to whether or not we'll adjust the prices. And in fact, we'll adjust the prices after that decision is made there and pass that back to the web bean for return to the customer through the servlet. I think that's pretty straightforward. So at this point, we have enough of the design done to begin putting the components in place. What we haven't talked about are the rules designs themselves and the decision processor, some of the more low-level design, but once we get into the implementation screencast, that will all be covered. And this concludes the end of part 2 for the screencast. Part 3, the demo application and component walkthrough, will be next. Thank you for viewing.